Hey everybody, Chris here again. Welcome back to the channel. Always good to have you with us. So today, we're going to look at something that I find pretty exciting. We're going to look at Novell NetWare 3.x in an emulated fashion, running on a Linux system. But not just any Linux system. I've got it loaded on this little Raspberry Pi that you see here. Kind of cool. So, I'm going to take you through the setup procedure on how to do this, to set up on a virtual machine. And to my right, we have a virtual machine running the Novell DOS client. I won't take you through how to set this up on a real machine like you see here on the Packard Bell Multimedia C110. However, the steps are pretty similar. All right, now rather than torturing you with a flickering screen, let's go ahead and kick this over to Virtual Chris, who's going to show us how to go through the process. So, Virtual Chris, take it away. All right, setting up Mars NWE with an MS-DOS NetWare client. Let's get started. So, as always, the instructions I'm showing you here on the right side of the screen are available in my Git repository because I like you guys. So, I will put a link in the description of the video so that you can find this, as always. This is a long procedure, but it's worth it. So let's get started. So talking about prerequisites, you're going to need to have to set up a Raspberry Pi and enable SSH. Now, we won't be covering that procedure today, but I haven't left you in the dark. If you go to the procedure, you'll see there's a link, and we can copy that link, and it will take you to my Raspberry Pi setup instructions. And actually, this is shorter than the procedure that we're going to do for everything else. So, you can follow that and get your Raspberry Pi all set up and ready to go. Excellent. Additionally, there are some drivers you need to download, including these network card drivers that we will be using, as well as these other network card drivers that we will be stealing the lsl.com utility for when we go to set up our NetWare client. And additionally, we're going to download something completely unrelated to what we're doing so that we can get a copy of NetX and IPX ODI. And I found, because I just so happen to have this networking card, that the Zircon Pocket Etherlink 3 adapter has these drivers in it. So we're going to download that as well. So that's what we're going to do. Download those files, and you'll have all of your prerequisites satisfied. Oh, plus one more. You're going to need a copy of your MS-DOS 6.22 installation disks that we will be using to install the client. So that's your prerequisites for today. So with the prerequisites out of the way, it's time to build the kernel. And I will warn you, building the kernel is a long process. So, plan to have an SSH window in the background for a long time, or perhaps you can perform this procedure directly from the console of your Raspberry Pi. Let's get started. Let me go ahead and close this browser window, and we will see a session to my Raspberry Pi has magically appeared. And the first thing we're going to do is clone the repository needed to build the kernel with this command here. This single branch syntax is really important. Otherwise, you will download every single branch of the repository. And you'll notice that we're downloading the 4.14.y branch of this repository so that we can build kernel version 4.14.x. This was essentially the last kernel version to have support for IPX, which is required for Novell networking. Sometime much later, perhaps after a cup of coffee or a full-course meal, the repository clone will finish. Perfect. So with this, we're ready to actually do some configuration and building. So I'm going to go cd Linux to change into this. And from there, we can go ahead and run a makefile to configure this particular installation or kernel source. for the Raspberry Pi Model 3B Plus. Now, if you don't have a Raspberry Pi Model 3B, there's probably a different parameter you need to pass in here, and we can go to this build set of instructions, and if we go here, we can scroll down and see that depending upon the Raspberry Pi that you have, you will need to pass in this different make command. But for the 2, 3, and 3 Plus, we pass in this command here. So that's why I've documented it in the procedure. Let's go ahead and run that. All right. With that, it will write the configuration to the .config file. Next up, we need to install a couple of libraries so that we can do a graphical configuration. So we'll go ahead and install the libncurses.dev and its corresponding dependencies. And in my case, I've already installed it, but you should be prompted to install that. Next, we can launch the graphical configuration utility by running a make menu config. So first, we're going to go into networking support, then networking options, and if you press page down 5 or 6 times, you should see the IPX protocol option. It's a little buried, but you'll see it. I think I went too far. Here it is. So I did 2 page ups. So there we have the IPX protocol. If we press the space bar, an M will appear. And that M basically specifies to build the IPX protocol as a module. So with that selected, we can tab down and choose exit, and then exit again, and then exit again, and then choose yes. Great. Now that we're all configured, we can go ahead and run this make command that you see here to build ZImage, modules, and DTBS. Now, usually this step will take several hours and scroll through several pages. But due to the magic of YouTube editing, I switched out the repository I downloaded for one that I had already built. So, in any event, like I noted earlier, just be ready and either plan to run an SSH session in the background or run it from the console of the Pi. Okay, so with the installation complete, we can go ahead and copy the kernel modules or install the kernel modules where they belong. First thing we're going to do is run this sudo make modules install. And next, we're going to run some copy commands. There are 4 of them. We can just paste them all into the terminal at the same time. Excellent. So let's scroll down just a little bit so we can see the rest of the directions. And what we're going to want to do is edit the boot config text file and add a line in here so that we can tell the boot.txt set up to use the new kernel that we just built, namely this kernel 7-ipx.image. And we'll save the file. And from there, we're ready to reboot. So we can do a sudo reboot. So naturally, with rebooting the Pi, the SSH window is going to close on us. So we're going to have to start a new session. And in the interest of full disclosure, for whatever reason, and this has happened to me twice now, my Pi actually did not reboot cleanly, so I had to go and pull the plug on it. This could be a function of trying to use an older kernel with a newer version of Raspbian, or perhaps something else is at bay. But anyway, we're rebooted now. Hopefully you don't have the same problem. Now that we're rebooted, we can check and make sure that we have the right kernel version running, and indeed we do. In my case, it's 4.14.114-v7+. The key thing here is you should have a 4.14 version. And as long as you do, you should be all set. Great. So next up, we're going to go ahead and build Mars NWE from source. So let me get this procedure queued up here. And the first thing we're going to need to do is install some support libraries. And in full disclosure, I've already installed them, but you'll see them install accordingly. Next, we need to download from source and build Mars NWE. So I'm going to do this wget command to get the bzipped file. We can then unzip it, and we can then untar it. From there, we can change into the directory and run cmake. And next we can run make. And once complete, we can run make install to install Mars NWE. So with Mars NWE built and installed, and by the way, we saw that went much faster than the kernel, we can now configure it. So to do that, I'm going to edit the configuration file and change a few sections. First thing we're going to do, just so that we can relax restrictions a little bit, is change section 1. So we can look down and see where we have this line starting with 1, and I'm going to change the net masks to 777. And this will allow any sort of directories or files to give basically world, read, write, and execute permissions. Again, we're not too concerned about security. If we were, we probably wouldn't be installing NetWare 3.12 emulation. Moving on. The next thing we're going to do is look for section 3 and completely comment it out. There should just be one line. But if we don't do this, we're not going to be able to access Mars NWE from a client. I spent literally hours banging my head against the wall figuring this out. Anyway, why do we have to do that? Probably because newer versions of Linux have some changes in them that interact differently, and Mars NWE is very old. Moving on, we're now going to go to section 4, and I'm going to comment out this second line and change this first line for ETH0, which is our wired Ethernet card, to be 802.3. Now, traditionally, NetWare 3.12 uses 802.2. However, I have found stability problems when running in a virtual machine connecting to the Raspberry Pi. As such, we're going to go with 802.3. So there's that. Perfect. Also, I will say this. You want to use a wired interface like ETH0 as opposed to a wireless interface, since wireless interfaces don't appear to traverse IPX traffic. All right, moving on. Section 7, we want to change the 0 here to an 8. And what this does is allow for unencrypted passwords, as we can see here. Perfect. Next, section 9. While not necessarily relevant, I'm going to bump up the masking here as well to allow greater permissions. All right. And next, we need to set a supervisor password. This can be anything you want. I'm just going to make it top secret like the example shows here. So the syntax here is supervisor, the user it maps to in the file system, and the password. Perfect. One final tweak, and this is just to support debugging and general interest. I'm going to change section 101 to be 99 to allow us to have ultimate debuggability for the NWServe process. With this, we can save the file. Excellent. I have some commentary here in the directions, but we've covered it as we've moved along. I'll leave it there for you to read if you so desire. Moving on. Let's go ahead and update our rc.local file so that on boot we can load NWServe. And there's a couple of things we need to do to support that. First of all, we need to make a var log directory if one doesn't exist, and we also need to make a var run directory if that does not exist. Why? Well, once again, Mars NWE is very old, and there were probably certain assumptions made for older versions of Linux that no longer hold true. However, with these 3 lines, we should be all set. I'll go ahead and save that. And There may be a better way to set this up, but this is how I know how to do it, so that's what we're going to roll with. If I hear a better way, I'll update the procedure and pin a post to the top of this walkthrough. All right, we're going to go ahead and reboot at this point. And to reboot, we need to do a sudo reboot. I will be fixing the procedure here in real time. And from there, the Raspberry Pi should reboot. So with the reboot complete, we can go and have a look and see what things look like. Let's go ahead and launch that terminal session. And generally, I just want to poke around a little bit. I'm going to scroll down to the troubleshooting section here. And we can look at, say, the IPX routes. And I see one route. That's a good sign. If you have, say, more than two, that could be problematic. Let's look at the NW serve log. And we can see some polling going on, some RIP responses. So it looks like there's activity. That's a very positive thing. We can also look at the ifconfig configuration, and I'm just going to grep for IPX. And we can see that IPX is associated with ETH0, also a good thing. And ultimately, if you get into trouble and need to kill processes, there's some commands for that as well. Great. Well, that's pretty much the server side setup. Let's have a look at the client. So to set up a NetWare client, we're going to use VirtualBox. I'll go ahead and get that launched here, and we'll drag it over just a little so we can actually read the directions. I'm going to click New, and I'm just going to type Novell Client, type DOS or other, version DOS, next. 16 megabytes of memory is plenty. Next. As for the hard drive, we're going to create a virtual hard disk. And we want it to be type VMDK. This will allow WinImage to open our virtual hard disk. And from there, dynamically allocated is fine. And we can click Create. Super. So once created, we need to adjust our network adapter. I'm going to go to Settings, Network, Adapter 1, and change this to be bridged. And I'm going to bridge to my wired network adapter. And click OK. Next, we're ready to install MS-DOS on this machine. So I'm going to click on Settings, Storage, click on this floppy, and then change the floppy drive to an image. And we'll choose a virtual disk. And I happen to have it here in my downloads directory of all places, disk 1. And we'll click OK. Now we're ready to power up the machine and install MS-DOS 6.22. Let me make this a little bigger so you can actually see it. That's better. So we're just going to press Enter here and configure unallocated disk space and press Enter to continue. From there, the drive is formatted and we can choose the settings are correct. And the DOS directory, I'll scroll down here in the directions. We're right here. So we'll press Enter. When prompted, we can put in the additional disks. And now it says to remove the disks. And restart. We will do that. Perfect. So now we have a plain vanilla DOS 6.22 installation. Let's power the machine down. So now we're going to inject some files into the virtual machine image. To do that, we will launch WinImage. And we need to navigate and open our virtual image, which is going to be located under C:users, your username, VirtualBox VMs, the name of your VM, and then there should be a VMDK file in this directory. There it is. Open that up Click OK. And now we can create a net directory, which I've already done, by using this image create folder option. And let's go ahead and inject two files in here. Let's go image inject. And using the prerequisites that we downloaded earlier, I can go to the LAN, NetWare, DOS, and grab this PCNT/NW COM file and inject it. And we'll say yes, and that's our first file. The next file we want to inject is the lsl.com file, which we can find from the Client32 download prerequisite. So, on that net directory, once again, image, inject, downloads, Client32. From there, we can find lsl.com and say open and inject. Perfect. Finally, we're going to inject the Pocket Etherlink 3 driver into the image. So we're going to come back up here to the root folder, create a folder. We'll call it PE3DRV. Then we'll select it, image, inject, navigate up, find that PE3DRV.exe file, and click open, and then yes. With this, we can close WinImage and restart the NetWare Client virtual machine. And the first thing we're going to do is set up the IPX, ODI, and NetX drivers. So we can change into this PE3 drive directory and run PE3DRV. Press Y every time you're prompted to continue extraction. And now we want to copy a couple of files into the net directory. So I'm going to copy ODI, ipxodi.com to c:\net, and also ODI netx.exe to c:\net. Great. So from there, we need to configure our AutoExec.bat startup to load all of the necessary NetWare drivers. So let's edit AutoExec.bat, and at the bottom of the file, let's add path equals c:\net, semicolon, and then path with the % around it. And then we can type lsl, PCNT/NW, IPX, ODI, netx, and then f:, because after we run that netx command, F drive will then be mapped to our NetWare share. Perfect. We can save and exit. And from there, we just need to create a net.cfg file because we're using non-standard Ethernet settings. So to do that, we can say edit c:\net.cfg, and we're going to add link driver PCNT/NW. Next line, a couple of spaces, frame ether net 802.3. With that, we can save and exit. With this, we're ready to reboot. And as we reboot, we can see the memory test, we can see all of our settings, the 802.3 Ethernet settings there as well. And we're all logged in, and we can see drive F. Poof! Mind blown. Isn't that quite the procedure? I had a lot of fun figuring that out, and as you saw in the commentary, there were points where I was banging my head against the wall, but I definitely got through it, so that's the fun part. I hope that you give the procedure a try. As I noted, the description contains the procedure to follow, and as you have experiences with this, share them in the comments. And as a community, we can look together and solve any problems that we come across. That's what it's all about. That's what this channel is all about, sharing knowledge amongst each other. So one other commentary piece I wanted to offer. As you noted, we did build this on an older version of the Linux kernel, so I'm not sure how sustainable this procedure will be in the future, but it works today. And fortunately, we can compile that older kernel and run on the Raspberry Pi today. Hopefully our luck holds out for the foreseeable future. All right, well, that's what I had for you today. Hope you enjoyed it. Definitely subscribe to the channel if you haven't already. If you liked the video, please do give it a thumbs up. If not, you know what to do. In any event, looking forward to seeing you next time. Always glad to have you along for the journey. And that's all for now. Bye.